So now we're going to talk about horizontal asymptotes. We talked about vertical asymptotes, but now we're going to talk about the horizontal ones. So if you remember, when we have our reciprocal function, there's a horizontal asymptote right at the x-axis, and there's also a vertical asymptote at the y-axis, and then the graph goes, something like this. That's the toolkit function. All right. So with horizontal asymptotes, there's three cases, kind of four, but we'll just say three cases. First of all, it goes by the degree of the polynomial in the numerator and the polynomial in the denominator. So if the degree of the numerator is less than the degree of the denominator. Okay, so let's just, degree of the numerator here is 1, and the degree of the denominator is 2 because it has an x squared. And so in this case, we have 1 is less than 2. So this is case 1. And what it means is that the horizontal asymptote is at y equals 0, or that's the x-axis. Okay, so you can see that from our reciprocal function. Our horizontal asymptote was at the x-axis. The degree of the numerator is 0, and the degree of the denominator is 1, and 0 is less than 1. Okay, so our cases for horizontal asymptotes have to do with the degree of the numerator and the degree of the denominator, the degree of those polynomials. Okay, so if it's less than, if the degree of the numerator is less than the degree of the denominator, it's just automatically at the x-axis. Now, I included some pictures for you so you could look at these. This is a graph then of this. And you can see it's got, a piece of the graph here where it's going toward this vertical asymptote at -5. So, if you were to factor, you'd see, there's a vertical asymptote at -5 and one at 1. Those are there. And then you have this horizontal asymptote. You see this piece in the middle. It's kind of curving through here. And then there's a piece of the graph that's going like this. Now, in an earlier video, I mentioned you can't cross vertical asymptotes. So you can't cross vertical asymptotes. However, you can cross horizontal asymptotes. They don't always cross, but you can. It's allowed. Okay, so you can see, like if you were like thinking, hey, that's crossing the horizontal asymptote, that's okay. All right. So case 2. Case 2 is when you have, this is the one that's kind of two cases. So the degree of the numerator is greater than the degree of the denominator. Then there's no horizontal asymptote. However, if the degree of the numerator is 1 more than the degree of the denominator, then you have what's called a slant asymptote. It looks like I made it a division thing, but it's not. It's called a slant asymptote. Well, I'll just point. It's called a slant asymptote right there. Okay, so that's because my degree here is 2, and my degree down here is 1. So if it's just 1 more in the numerator than the denominator, you get what's called a slant asymptote. The way you find the slant asymptote, let me show you the picture here. So this is the slant asymptote. It's like a linear equation, but it's not horizontal, it's not vertical, it's got a slope and it's got a y-intercept and things like that. So the way to find that slant asymptote is you actually do this division. So you could say, you could do it synthetically or with long division. If I do it synthetically, it would look like this. We don't really care about the remainder. What we care about is this, 3x plus 1. So when y equals that, that is the equation of the the slant asymptote. So if you're graphing these and you know you have a slant asymptote, you can find it. You just have to divide out the polynomials. And that's why it can only be 1 degree more. Otherwise, you wouldn't get a linear function. Okay, so that's the case of the slant asymptote. And notice that you have this curvy thing going in here, you know, kind of approaching those asymptotes. And then there's another piece up here approaching those asymptotes. So you might have a slant asymptote. Okay. And then finally, case number 3. Did I put case 2 up here? This is case 2. You have, back to case 2, you don't get a horizontal asymptote if the degree of the numerator is greater than the degree of the denominator. If it's only 1 more, then you get a slant asymptote, but you still don't get a horizontal asymptote. Okay, and then finally, case 3. The degree of the numerator equals the degree of the denominator. Then you do get a horizontal asymptote, and what happens is you're looking at these two leading terms. So you have 3x squared over x squared, or 3 over 1. Now, when you're thinking about these polynomials, what's going to have the biggest influence on your polynomial? The term that has the highest degree, right? Okay, so because you square something, that's going to take more effect than if you're just, like in this case, multiplying by 4. So that kind of has the overall leadership of how this graph is going to look. And so you could put in numbers and you can see that and stuff. But what's going to happen then is those coefficients, 3 over 1, that's going to be the horizontal asymptote. So and then we have a picture here as well. So here's the horizontal asymptote. You've got a piece of the function going like this, approaching that vertical asymptote and the horizontal asymptote. Then you've got this piece in the middle doing this type of thing. And then finally you have this piece here. It's coming down, it's crossing the horizontal asymptote, but eventually it starts to approach that horizontal asymptote. So that's what we're looking at when we're looking at these horizontal asymptotes. Okay, so we'll give you some examples in the next video.